Hello, everyone. The sun is one of the most powerful feelings we can feel. Starting from the first light of the morning until the following hours, the warmth we experience on our skin gives life to the whole world simultaneously. As a source that makes us love nature and makes us feel survivors, she hides it from her surroundings every day. The cost to the sun is our feelings that we are connecting with something much greater than ourselves, which has existed for billions of years and will continue to exist long after we see it destroyed. With its distant character seen as a symbol of hope on Earth, this gigantic ball of gas is almost hot, chaotic, and hostile. We say it is hostile because Mercury, which is only 58 million kilometers away from the Sun, is one of the unlucky planets as it sees the destructive effects of the Sun. During the long Mercury days, the temperature rises to 430 degrees Celsius, enough to melt lead. However, the thin layers of the atmosphere cannot trap the heat, and the temperature drops to 180 degrees at night. No other planet in the solar system has such a temperature difference. Up close, isn't it so invigorating? Fortunately, thanks to the Earth's magnetic field, we are largely protected from the sun's destructive effects. But last week, the National Aeronautics and Space Administration announced that there are 20 Earth-sized holes in the sun's corona. The giant hole in question can send solar winds to the Earth at a speed of 2,896,000 kilometers. Scientists spend quite a lot of research on how this hole will affect our world, with you before the solar winds hit to spread out. In this video, we'll explore some amazing features of the sun, swaying in the solar winds, and learn what waits us Earthlings as a result of that wind. Sit back, relax, and let's dive into the fascinating creatures of the sun. Formed by the collapse of a molecular cloud about 4.6 billion years ago, our sun consists of a dense gas mixture. Thanks to its immense gravity, it not only holds helium and hydrogen together, but also has enough force to keep the planets in its orbit in a certain orbit. The sun is thought to be not very large compared to red giants, the largest known star type, but rather large compared to red dwarfs, the smallest star type. In short, although the sun is not the largest type of star in the universe, it is larger than most stars. With these qualities, the sun is just an old, average star by universal standards. The diameter of the sun is 1.4 million kilometers. The sun, 110 times larger than the Earth's diameter, has a volume equivalent to 1 million times the Earth's volume. It is a sphere of gas like other stars. It consists of 91.0 hydrogen and 8.9 helium in terms of atomic number. The enormous mass of the sun is held together by the force of gravity. It generates a tremendous pressure and a high amount of temperature in its center. The sun has 6 regions: the core, the radiative region, and the inner convective region. The visible surface called the photosphere, chromosphere, and the outermost region, the corona. In the core, the temperature is about 15 million degrees Celsius, which is enough to sustain thermonuclear fusion. This is a process where atoms combine to form larger atoms and release large amounts of energy in the process. Specifically, in the sun's core, hydrogen atoms combine to form helium. The energy produced in the core powers the sun and produces all the heat and light emitted by the sun. The surface of the sun we can see is about 5,500 degrees Celsius. That means much cooler than the burning core, but still hot enough to boil carbon like diamond and graphite, not just melt it. What prevents the sun from collapsing on itself is the conversion of hydrogen in the sun into helium through the fusion reaction and the energy released in the process. This is why hydrogen is said to be the fuel of the sun. When this fuel runs out, the sun will die too, scattering material to form even larger elements. But don't worry, this hot plasma is expected to die after 5 billion years. Now that we're talking about the solar core, let's get a little closer to the surface. The photosphere, the surface of the sun, is a 500-kilometer, thick region where most of the solar radiation escapes. This is not a solid surface like the surfaces of planets. Instead, it is the outer layer of the star, consisting of gas. We see radiation from the photosphere as sunlight when it reaches Earth about 8 minutes after leaving the sun. The temperature of the photosphere is about 5,500 degrees Celsius. The temperature of the chromosphere, which can reach about 2,000 kilometers from the photosphere, can rise from 6,000 decks to 20,000 dec. The reason why the sun appears red during total solar eclipses is that the hydrogen atom glows reddish at high temperatures in this region. The high temperature of the chromosphere is thought to originate from the photosphere. The corona layer can only be observed during total solar eclipses. Although we do not have certain information about why the corona layer, which has an average temperature of 2 million Kelvin, is so hot, it is thought that the magnetic field of the sun is effective in this situation. The surface of the sun is a moving field. The electrically charged gas creates a strong magnetic field. The gases in the sun are constantly moving, which entwines, stretches, and bends magnetic fields. This motion creates a lot of activity on the sun's surface, which is called solar activity. Sunspots appear as dark areas on the sun's surface. They appear dark because they are colder than other parts of the sun. Yet the spots are still very hot, approx. 3,600 Why are sunspots relatively colder? Because the magnetic field in their region is particularly strong. These magnetic fields are so strong that they prevent some of the heat inside the sun from reaching the surface. Magnetic field lines near sunspots often become entangled, crossed, and rearranged. This causes sudden bursts of energy called solar flares. Explosions scatter large amounts of radiation into space. If the explosions are too intense, the emitted radiation can disrupt radio communications on Earth. Solar flares are sometimes accompanied by a coronal mass ejection. Mass ejections are large bubbles and particles of radiation from the sun. When the sun's magnetic field lines are suddenly rearranged, they explode and spread out into space at very high speed. Charged particles reaching the Earth from the mass ejection cause natural radiations called aurora in the sky. When the mass ejection is too strong, it can cause power outages in the worst case. Solar flares and coronal mass ejections are the most powerful eruptions in our solar system. The sun doesn't always behave the same way. The solar cycle has phases. About every 11 years, the sun's geographic poles change their magnetic poles. When this happens, the sun's photosphere, chromosphere, and corona changes from quiet and calm to fiercely active. The height of solar activity, known as the solar maximum, is the time of solar storms. Sunspots, solar flares, and coronal mass ejections increase. These are caused by irregularities in the sun's magnetic field. Some solar winds can even release large amounts of energy and particles that reach Earth. This space weather can damage satellites, erode pipelines, and affect power grids. The U.S. National Aeronautics and Space Administration detected a second dark spot on the sun's surface within a week. This black spot, called a coronal hole about 20 Earth-sized, is not dangerous to our planet, but may have some impact on Earth. The coronal hole is expected to send solar winds towards the Earth at a speed of 2,896,000 kilometers per hour. But don't worry, it was stated that these winds do not pose a threat to the world. Scientists announced that the winds expected to reach the Earth on Friday will not damage the electronic infrastructure, but will only create the northern lights in some regions. Chaotic, deadly, uncontrollable. Despite its devastating effects, the sun continues to give us life for centuries. When it gets old enough, as a result of the depletion of hydrogen atoms in the core, the helium atoms accumulating there will become unstable and begin to collapse. This will cause the core to heat up and condense, and the sun will become larger and larger. Entering its fate is called the red giant branch. As a result of this expansion, the sun will engulf Mercury, Venus, and perhaps Earth in its orbit. Quite a bitter end. That's all from us for today. If you want to see more sun-related content, you can continue to follow our channel. You can also share with us any sun-related topics that you would like to be addressed in the future in the comments section. Thank you for supporting us, and see you in our next video.